Happy Monday, Building Science Geeks. It's me, Mariana Pickering from Emu, and we are here for another one of our Monday BS Building Science sessions. The thing I'd like to talk about today is a phrase that gets thrown around a lot in the construction industry and outside of it, unfortunately. And we're going to bust that myth today. Walls do not need to breathe. What needs to happen is that a building needs to breathe through a dedicated mechanical ventilation system. A lot of the confusion about walls breathing also just comes from a misunderstanding about how air and moisture migrate through assemblies, which is not the same way, and kind of a misunderstanding about the order of magnitude of where danger is. So one thing that has come up for me a lot, even in building science conferences, is that I've noticed that people kind of interchangeably talk about vapor diffusion and air exfiltration. But what we know from scientific studies is that air exfiltration can actually carry 30 times more water vapor than simple air diffusion. Now, if you're like, what are you talking about, Mariana? Air diffusion is where the air is still, but the water vapor is just kind of moving from a high pressure to a low pressure situation through a solid assembly. However, air exfiltration, which is actual movement of air, so going from the warm inside to the cold outside, that air is looking for a path through the assembly. And that's super dangerous because, like I said before, it can carry a lot more water vapor with it. And then it just kind of deposits that water vapor at the point where it gets cold. So it can condense on wood or on metal, cause biological decay, mold, corrosion in metal, things like that. So unfortunately, when someone is pushing for the idea of a wall breathing, or even when, we saw somebody install a window intentionally with cracks around it to allow the wall to breathe, you're basically just opening up points for air exfiltration to deposit water. And this is, massively important for the durability of our buildings. We have a lot of buildings right now in the United States with moisture-driven damages in them. It's also important to remember that you can still have a lot of damage to a building inside the wall assembly, even if it's dry. A high relative humidity will cause wood rot and biological decay. So you really want to have a controlled air barrier. You want to have a strategy using vapor retarders to understand the vapor diffusion. And then you want this airtight barrier to be continuous so that you don't have spots where things leak out, where air leaks out and takes water vapor with it and condenses on your assembly. One of the analogies that we like to use in our training when we talk about the phenomenon of walls breathing is this little animal, the salamander, which to my knowledge is one of the biggest, if not the biggest, organism that does actually breathe through its skin. But it's a pretty inefficient, non-compact form. It's a very delicate animal that needs a certain environment to live in. For me, the salamander analogy is really helpful because when I think about a building, I almost think about it as an organism, and the building envelope is the skin. And in a passive house, and the reason that I'm so passionate about the passive house standard or similar to it is that it has the requirement for a mechanical ventilation system, which acts as the lungs of the building and really controls not just the continuity of fresh air exchange, but the quality of it. And that's super important. So the big thing to remember here is no, walls do not need to breathe. Feel free to correct people on that. Buildings need to be airtight for energy efficiency and for a controlled strategy as far as avoiding moisture-driven damages. Once you have an airtight building, you need to think about indoor air quality. And in order to do that, you do that through understanding and designing a mechanical ventilation system that supplies continuous fresh air exchange, and really ideally should be designed in tandem and in integration with the building envelope strategy. This is why passive house is such an important benchmark in our industry, because it's a standard that by certifying to this level, you are guaranteeing that you're supplying continuous fresh air exchange with heat recovery incorporated into it, which is a whole other topic we can get into at some other point in time. But really addressing indoor air quality through controlled and dedicated mechanical ventilation, not uncontrolled and dangerous wall breathing. So thanks everybody for joining me for another Monday BS. If you have any suggestions on topics that you'd like broken down into more simple terms, please let me know in the comments, and hope you all have a great week. Thank you. Bye.